should have already watched your videos. These are just some samples of some of the homework problems you'll have in lesson 9.5. In fact, some of them are some of the problems you'll be doing, so you should follow along. So the first few problems, you're just finding different values of the function. So all you're going to be doing is plugging in those values. So for f of -2, that means you just want to plug in -2 wherever you see an x in the function. So it's going to be a -2 plus 1 over -2 squared. You figure out what that's equal to. -2 plus 1 is -1, and -2 squared is 4. That's your first one. F of 0, you might notice what happens with this right away. I'll show the work. You end up getting, putting 0 in for x in both spots, and then we get 1 over 0, and we can't divide by 0, so we see that this is undefined. And that's important. That happens often in rational functions where you have an undefined thing that will relate to vertical asymptotes. That will go over a couple problems that deal with that. Finding f of 3 just means we're going to put 3 in for x. So 3 plus 1 over 3 squared. And we get 4 over 9. And so that's evaluating at those different spots. The next example, vertical asymptotes. Vertical asymptotes occur at values that make the denominator 0. Let's say at x values that make the denominator equal 0. And so all we're doing is we're figuring out what values of x make the denominator equal 0. So what can you put in here that makes this 0? Well, for number 5, the vertical asymptote, and vertical asymptotes are written in the form x equals a number. So we put x equals, and what makes this equal 0? Well, it's 0. You must put x equals 0. Don't just put 0. Put x equals 0 because that is a vertical line. So that's your vertical asymptote because that's what the value that makes the denominator equal 0. For number 6, a little bit different. What makes this equal 0? Well, it does help to factor it. So we're figuring out what makes this 0, so we're going to take x squared minus 1 and realize that is a difference of squares. That's x plus 1 times x minus 1. So what values of x makes this equal 0? So x is equal to -1, because that makes this equal 0, or +1. And those are your answers for the different vertical asymptotes. You have to put x equals. Any intercepts for these functions? So the next section, this is the directions. So first we'll look at x-intercepts. X-intercepts, what we think is we plug in 0 for y, but what we can, which this goes along with that, if we want a fraction to equal 0, we know that the numerator has to equal 0. And so x-intercepts occur when the numerator equals 0. So we mentioned in the last slide that vertical asymptotes occur when the denominator equals 0. X-intercepts occur when the numerator equals 0. We could have said the x-intercepts occur when at the x values that make the numerator equal 0. So what makes the numerator equal 0? Well, -8. So we have an x-intercept at -8. In fact, an x-intercept is a point, so it's at the point -8, 0. I would just accept -8 because it says where's the x-intercept? -8. Y-intercepts, we worked through this when we talked about lines and other things, but y-intercepts occur when you set x equal to 0. So we're going to plug in 0 for x, and I'm going to make this a y equals instead of an f of x equals. So y-intercept equals, we're going to plug in 0 for x, 0 minus 8 over 0 squared minus 4. That gives us -8 over -4, which is 2. And so our y-intercept, you can say the y-intercept is at 2, but even better is to put 0, 2, because it's a point. Sometimes there's more than one y-intercept. Sometimes sometimes there's more than one x-intercept. There is only ever one y-intercept. Next one says to give the domain. Well, domain, that's really asking basically the same question as this, but almost exact opposite. Here you want to know the vertical asymptotes are. Well, vertical asymptotes will not be part of the domain. So when we're asked to find the domain, we're just stating the values that make the denominator equal 0 and saying x can't equal that. So the way to write that, when we list domain for functions, it's assumed that it's all real numbers. So what we do is we write x, so this means all values of x, so that x does not equal, so the only thing that it can't equal is -1, because -1 makes the denominator equal to 0 and we cannot divide by 0. And then for the other one, the domain, it's all values of x so that x does not equal. And what makes the denominator 0? Well, the only thing that makes it 0 is if x were 0. So that's listing the domain. So you just write all values of x so that x does not equal whatever would make the denominator equal 0. And the last one is a graphing one. And what we do is we use the concepts we talked about earlier. We want to find the x-intercept, and we learned that the x-intercept is what makes the numerator 0. So the x-intercept is supposed to be a colon, is what makes the numerator equal 0, well, x equals 1. And so we have an x-intercept at 1. Our vertical asymptotes are the values that make the denominator equal 0, which is 0, x equals 0. So that's a vertical asymptote. So that's going to be, vertical asymptotes never get intersected by the graph, so that's going to be a vertical asymptote on the y-axis. Sometimes we would find the y-intercept. Remember, we find the y-intercept by plugging 0 in for x, so that would be 0 minus 1 over 0 squared. But we notice that's going to be undefined because we're dividing by 0. So if there's a vertical asymptote on the y-axis, there will not be a y-intercept. Once you do that, what you can do is just plug in several x values into your function and find the corresponding y values. And so I'm going to try to do this somewhat quickly, but I'm going to choose maybe -3, -2, -1. I can put 0 in, but I see when I put 0 in, I'm going to get undefined. I can put 1 in, but I also notice when I put 1 in, I'm going to get 0 because that's an x-intercept. 2, 3. So putting -3 in, all I'm doing is plugging it into this function. So -3 minus 1 over -3 squared. My writing's not so good, so this is a -3 minus 1, which is -4, over -3 squared is 9. So at -3, we have -4/9, which is about right here. -2, I'm not going to write out all the work, I'm just going to look up here. -2 minus 1 is -3, over -2 squared, which is 4. So we have -3/4. So that's down a little bit. -1. -1 minus -1 is -2. -1 squared is 1. So we get -2. And we notice it keeps going down. And that makes sense because our vertical asymptote is here. So this is going to keep coming down this way. Another thing we can notice over here on this part, anytime I put a negative number in, like if I put -5 in or -10, we would get a negative number top and a positive number on the bottom. A negative divided by a positive is always negative, which it means it will never go over the y-axis because above the y-axis would be positive, but it never will be positive. I'm going to jump over the other side here of the y-intercept or y-axis, and I'm going to plug in 2. 2 minus 1 is 1. 2 squared is 4. So when it's 2, it's 1/4. Something interesting happens here. So -2 is 1/4, or sorry, 2 is 1/4. 3 gives us 2 over 9. That's a little less than 1. I put this in the wrong spot. That's positive. It should be above the y-axis. This is 2/9. It's a little closer to the x-axis. If I put in 4, I'm going to get 3/16, a little closer to the y-axis. And so we're going to end up having an asymptote on this side too. So our graph's going to get closer and closer to the y-axis, but it goes through the x-axis here, and we want to see what happens in between 0 and 1. So I'm going to put 1/2 in here, and I'm going to write out my work. So we would have 1/2 minus 1 over 1/2 squared. 1/2 minus 1 is negative 1/2. This is 1/4. Well, dividing is the same as multiplying by the reciprocal. And we get negative 2. Oops, that should be a 1. And so we see this goes down. And so this graph ends up looking like this. So when you're graphing, wow, that was pretty sloppy. Find your x-intercepts, find your vertical asymptotes, graph several points, and that should help you find this. You'll oftentimes have a vertical asymptote and a horizontal asymptote. And that is some sample problems for you.